Okay, so if you look at a graph like this, a horizontal asymptote and a vertical asymptote plays a different role. So let me just write it down in terms of functions. The horizontal asymptote, right, is meant to deter you from your graph cutting through 3. Why? Because 3, right, must not be inside the domain of the function here. Okay, why so? It could be by design of the question, or by virtue of the fact that 3 is a value that will cause the denominator or the function to be undefined. Hence, it must be excluded from the domain of the question. Hence, by virtue, right, it means that it must be excluded from the sketch, right? So we draw a dotted line there as a boundary to deter you from having your graph passing through that dotted line. Okay, but a horizontal asymptote, right, plays a different role. A horizontal asymptote, right, based on this question, right, this picture, right, is to show you the eventual behavior of the graph, or what we call the asymptotic behavior of the graph, has x goes to infinity or negative infinity. If you look at this picture, the highlighting makes it blur. Okay. If you look at this blue graph, right, has at the eventual end, whether it's on the right side or the left side, x, or should I say y, goes to 2, right, or hovers around 2. So what does the horizontal asymptote does for you here, right? Okay, so this is vertical asymptote. This horizontal asymptote, right, is actually trying to tell you, okay, has x goes to infinity or negative infinity, right, your y goes to 2. Understand? So this is trying to tell you that a graph can actually, but it doesn't really speak about whether the graph can be equal to 2 in the interim period, right? In the intermediate values, which are here, for example. In this case, it actually happened, right? Y was equal to 2 right here. Understand? So this is the description of a horizontal asymptote. It doesn't tell you whether the function can or cannot be 2 in the interim values, which in my example here, it actually went into 2 in the interim values. Can follow what am I trying to say here first?
How did it go to 2?
Because the function really cut, because if you see this part of the function, it actually cut 2 in the interim, right? That means at that particular moment in time, the y value is 2. Correct?
Yeah.
Because a lot of people always think a graph cannot cut the horizontal asymptote, which is wrong, okay? A graph can cut the horizontal asymptote in the interim values. The horizontal asymptote is just to tell us what happens to the function as x goes to infinity or negative infinity, that's all. Can follow?
Yeah.
So this is the first thing about horizontal and vertical asymptotes that you all must be clear first, okay? Vertical asymptote cannot cut. Horizontal asymptote can cut, okay? But doesn't mean that it must cut. But what is more importantly, a horizontal asymptote is trying to tell you the eventual behavior of the graph, okay? Which is very useful for us when we study logarithmic or exponential functions or their reciprocal, okay? So this is the second kind of reciprocal functions you are expected to sketch. Okay, so I'll just carry on to use this example as to sketch the reciprocal. Okay, so if you look at this, right, let's get the things out. More importantly, most of the things you all know how to do already, right? Let's just say this point here is a -1, -2. Okay, so this was a turning point and it's a minimum point. So you all can do most of this already. So actually, might as well sketch here. Horizontal asymptote, vertical asymptote, then you have your okay, so let's say cuts at 5, okay? Then your graph on top will be something like this, say like this. Okay, so this is cut at 7. This cuts at, this is 1/2. Okay, so this is the original graph. Okay, and then if I'm interested in sketching the reciprocal graph right now. Okay, everyone can follow the story. So based on this graph, right, the blue graph, right, has x goes to infinity or negative infinity, my y goes to 2, right? Agree? As illustrated here and here. The graphs at the eventual end will never breach 2. Okay? It will never cut the asymptote. But just like in the interim, it actually went through 2. So in the interim, it actually had a y value of 2, but not at the eventual end, that's all. Okay? All agree on this? Yes, no, yes?
Yes.
Okay, so now what will be the horizontal asymptote of the reciprocal graph then? Back to definition, okay? So you can see that as x goes to infinity, f goes to 2, right? So naturally, by algebraic implication, 1 over f must go to 1 over 2, isn't it? And hence this 1 over 2, right, is your new horizontal asymptote. Understand? Can follow now? Because x, the transformation is on the y, not on the x. So it's still 1 over f. Don't worry about this is 1 over infinity or whatsoever. Okay, can I understand my argument here? Yes, no, yes, guys? Can follow? Can guys?
Okay, can.
Okay, so the usual gameplay, okay? So with the additional horizontal asymptote, so y is equal to half, right? So this minimum point had a y value of half, so it must be this point. Okay, the drawing will be quite ugly, sorry for this. Y is equal to half, okay? Then your vertical asymptote become, so vertical asymptote, x is equal to 3 becomes a root, which is right here. Okay, then 5 was a root, it becomes a vertical asymptote now. Okay, then y-intercept was 7, so it becomes 1 over 7. Wow, it's going to get ugly. Minimum point of 1/2 becomes a maximum point of 1 and 2. Okay, sorry for the mess, but okay so far.
Okay.
Okay, so we look focus on any one detail at any point in time. Okay, so we focus on the 5 and above first, which is this portion here first. Okay, so 5 and above, the blue graph, right, is positive and increasing, right? Positive and increasing towards 2. Okay, so now the reciprocal will be positive and decreasing towards half, but never breaching half, just like how the blue graph never breached 2, at least from 5 onwards. Okay, so the red graph will be something like this. Okay, never breaching half. Understand? Can follow?
Okay.
Then the second portion. The second portion is here, negative and increasing. Understand? So it will be negative and decreasing towards infinity. So it will be like this, negative and decreasing. So it will be, okay, it cannot be a shape that's like this because it will breach the asymptote. Okay, so it must be the shape that I first drew, like this. Okay, can follow?
All right.
Then after that, in the interim, right, is here. If you look at this part here, the blue graph was positive and increasing. So now it will be positive and decreasing. You had a maximum point of 1, 2 plotted out already, right? So it will be like this. Oops. Okay, it's supposed to be a smooth curve. Sorry for this. Okay, then this side is a turning point. So you'll be turning towards the 1 over 7 now. Okay, understand?
Wait. How did you get that one?
Which one?
The latest one, the last one you drew.
This one, is it?
Yeah.
Because 1, 2 is a maximum point, right?
Mm-hmm.
Then it must come towards the y-intercept of 1 over 7. Right?
Okay, but I thought that portion is like positive and then decreasing. So this one must be positive and increasing.
Wait. You mean this portion, is it? Or the one on the right?
Yep, this portion, the one that you just
Okay,
highlighted.
the blue is positive and decreasing, right?
Mm-hmm.
So the red will be positive and increasing, right?
Yep, that's right.
But increasing is, if you read this way, it's actually increasing, right?
Oh shit, okay.
Yeah, you must read from left to right, not right to left, okay? Can you understand?
Yep.
Okay, then the next portion, right, is to see, okay, the blue graph, wow, okay. So now from here, right, it will just be hovering. Then after that, 1/7 was below 1/2, right, which is the horizontal asymptote. So 1/7, it will just be hovering around the horizontal asymptote now. Then that's it really. Sorry for the mess, but the analysis is like this. Okay, I give you all some time to digest every single bit. Okay, the key is always split this into sections and analyze it bit by bit. Okay, then the one thing that I want to highlight to you all is this. Okay, can you follow? Not sure,
Yeah.
sound off right away. Okay, if anything need me to clear, just sound off right away also.